Okay, so section 2.3 is about graphical misrepresentations of data. So again, I think you've heard me say before that one thing about statistics that we need to be careful of is that you can make statistics say anything that you want. So here's going to be some examples of how you can misrepresent data. Okay, so our objectives are going to be to describe what can make a graph misleading or deceptive. And statistics is the only science that enables different experts using the same figures to draw different conclusions. Again, that is the biggest thing about statistics, is that you can really make them say whatever you want. Okay, so here for a misrepresentation of this data, the data in the table represents the historical life expectancy in years of residents of the United States. We're going to construct a misleading time series graph that implies that life expectancies have risen sharply. And then we're going to construct a time series graph that is not misleading. All a time series graph is we're just going to plot a point, X, Y, plot a point. Next piece of data, X, Y, plot a point. And then you just connect each successive point. So it's not going to look like a straight line. It can be like a jagged line. And you'll see on the next slide what I mean by that. Okay, so the first one, again, we want one that's misleading. So we went from 1950 to 2000. So I am going to make this the year 50, 60, 70, 80, 90, and 2000. Johnson 00. And then for our life expectancy, we had a low of 68.2 and a high of 77. So I'm going to go from about 68 to 77. So I'm going to start at 68 here. Okay, and again, I'm going to put a little heartbeat in there just to show that my data isn't starting at 0 there. Okay, and I'm going to make every line worth 1. And I'm just going to write every other, though. So this would be 69, 70, 71, 72, 73, 74, 75, 76, 77, and 78. Okay. So now all we're going to do is plot points here. And again, see what happens. So in 1950, you had a life expectancy of 68.2. So that would be approximately right there. And then in 1960, it was 69.7. So almost 70. In 1970, 70.8. And 1980, 73.7. In 1990, 75.4. And in 2077. Okay, and again, we're just going to connect those dots, each one successively. Okay, so when you look at that graph, again, if you think of this as a ski slope, this is a pretty steep slope. So it looks from this graph like life expectancy has risen dramatically over the years. Okay, so now if we want to do one that's not misleading, what I'm going to do is I'm going to not make so much space right here so that we have a better representation of what's going on. So again, on the bottom across my x-axis, we're still going to make that the year, and I'll do it the same exact way. So 50, 60, 70, 80, 90, and 2000. But this time I'm going to count by 5. So I'm going to include everything that I skipped over here. So I'm going to go 5. And again, just to save space so it's not so mush, that's 10, but I'm not going to write it. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, and 85. Okay. So again, we're going to plot our points, but this time we'll see what our graph is going to look like. So in 1950, again, we had 68.2. So that is going to be approximately right there. 1960, 69.7. Oops. 69.7. Got to be careful where I touch on my screen. 1970, 70.8. 1980, 73.7. 1990, 75.4. And 2077. And now if I connect those dots and I look at that, same data here to here, but look how different they look. Hey, again, the one on the left implies that we had a huge rise in life expectancy from 1950 to 2000, where when I look at it on graph B, you can see that it's not as dramatic as what it looks like in A. And again, you can put this into Excel again, and Excel can spit out the time series graph for you. So again, this is the same one that I just did by hand, and that's the other one. And again, you can see the difference there. Okay, so the National Survey of Student Engagement is a survey that, among other things, asked first-year students at liberal arts colleges how much time per week they spend preparing for class each week. The results from the 2007 survey are summarized on the next slide. Construct a pie chart that exaggerates the percentage of students who spend between 6 and 10 hours preparing for class each week, and then construct a pie chart that is not misleading. Okay, so you can't really do this at home. I'm going to show you what we're talking about here. Okay, for one that is going to be misleading for part A. Again, here is the representation of your data, by the way, the data that they collected. Okay, and the central angles that are going to go along, again, if you want your central angles, you're going to multiply by 360. This is going to be eventually for your pie chart. Okay, and when you do that, you'll have 0, 46.8, 90, 82.8, 64.8, 36, 21.6, and 18. Okay. So again, first one that we want to do is we want to do something that is going to be misleading and exaggerate from 6 to 10. Okay, so we want to exaggerate this one. And again, you can't do this at home. What I'm going to do is I'm going to do a 3D pie chart. So again, if you put this into Excel, it can do that for you. So here's what it looks like. You can see 6 through 10 over here is represented by this color. And that is this section right here. And because this is 3D and because you're staring at that chunk that I just circled, look at my red circle compared to the rest of that graph. That red circle looks like it takes up most of that 3D graph when that is not the case. Okay. So one thing that we're going to avoid is we're going to always avoid using 3D. Okay. When you're using 3D on a 2D plane, so like my screen right now is 2D, but I'm projecting something at you that's supposed to be 3D. That's always misleading. Okay? However, if you ended up drawing a pie chart with not 3D, and again, you can use your protractor to do this. Again, I am not going to ask you to ever draw the pie chart using the protractor outside of that last section that we had talked about in 2.1. This is what it would look like though. Okay, and now you can see, again, here's that same 6 to 10, same colors I used on the other one inside of Excel. And again, that's over here. Okay, it still takes up a good chunk of it, but not nearly as much as the other slide had shown. Okay, so guidelines for constructing good graphics. Okay, you want to title and label the graphic axes clearly, providing explanations if needed. Include units of measurement and the data source when appropriate. You want to avoid distortion. And you never want to lie about the data. Again, you can make the data say what you want, but you don't want to lie about it. And we want to minimize the amount of white space that you use in the graph. Okay, use the available space to let the data stand out. And if scales are truncated, be sure to clearly indicate this to the reader. Okay, so the time series graph is really the only one that you kind of want that white space in. When we talked about those two graphs, we had one that kind of looked like a sharp increase, and then our second one looked like not so much. This had a lot of white space in it, but again, time series is going to show you what's happening over time. And again, that's the only one where white space would be okay, because you don't want to exaggerate the increase like you did over here. Okay, truncated, again, that was when on the left-hand one that we had done when we started our data at 68, I put that little heartbeat in. Okay, I did indicate to the reader that it didn't start at 0, but again, if you are not a mathematician and you see that heartbeat, you might not know what that represents. Okay. Other things that you want to do, you want to avoid clutter, okay, such as excessive grid lines and unnecessary backgrounds or pictures. You don't want to distract the reader from the data. And again, said this on the other slide, you want to avoid 3 dimensions. 3-dimensional charts may look nice, but they distract the reader and often lead to misrepresentation of the graphic. And again, specifically because when you're looking at something 3D on a 2D plane, again, it screws with your mind, and it distorts your data. Okay, do not use more than one design in the same graphic. Sometimes graphs use a different design in one portion of the graph to draw attention to that area. Don't try to force the reader to any specific part of the graph. Let the data speak for themselves. Okay, and avoid relative graphs that are lacking data or scales. Okay, you're going to see examples of this inside the textbook in the examples. Okay, and that is pretty much it. So tomorrow we're going to work on the classic from this section from 2-3.